What is AI? If you work in a professional environment today, AI is already in your workflows. It may be drafting emails, summarizing documents, screening resumes, and in many cases, it's doing so quietly. Before we talk about governance, regulation, risk, strategies, or productivity, there's a more basic requirement: clarity. Because organizations everywhere are making decisions about AI without a precise, shared understanding of what it actually is. So, this video is foundational. If we don't define AI properly, everything built on top of that definition becomes unstable. So, let's define it properly. You've heard the term 1,000 times: artificial intelligence, AI. It sounds massive, technical, almost mythical. And yet, if you stop most professionals mid conversation and ask them, what exactly is AI? Well, they would hesitate. And that hesitation matters. Because once a system begins influencing hiring decisions, credit approvals, medical screening, writing, research, strategy, well, vague understanding is just not enough. If you don't understand what something is, you can't responsibly decide how to use it. So today we're going to do something very simple and very precise. We're going to define AI clearly. By the end, you'll see why it is both less mysterious than most people assume and far more structurally powerful than they realize. And the power isn't where most people think it is. We'll come back to that. When most people hear AI, they imagine something thinking, reasoning, or understanding. But underneath the branding, the interfaces, the voices, the conversational polish, AI is something much more specific. At its core, modern AI systems detect patterns in data and use those patterns to generate predictions. That's the foundation. Pattern, pattern detection, prediction. Let's make that concrete. If you type half a sentence in your phone and it suggests the next word, that's prediction. If a fraud system evaluates a transaction and decides it looks suspicious, that's also prediction. The system looks at what has happened before in massive data sets and calculates what is most likely to happen next. It doesn't know in the human sense. It estimates probability. And when probability becomes extremely refined, it can feel like it's understanding. That feeling is where some confusion comes from. Let's use a simple analogy. Imagine you have a massive box of Lego pieces, not a small one, like warehouse size box. Inside it are millions of fully built Lego sets that were taken apart: castles, cities, spaceships, bridges. Now, imagine someone gives you a single red Lego brick and asks what piece usually comes next. Well, if you've seen enough finished sets before them being dismantled, you can make an educated guess. Not because you invented something or you're a pro in Lego sets, but because you've seen the patterns. So, a 2x4 red brick tends to connect in certain structural ways, corners connect in predictable sequences, and it's most likely not seen on a spaceship. So, you're predicting the most likely continuation based on past patterns. That is what modern AI does. It's trained on massive amounts of text, images, audio, and numerical data. It doesn't invent structure out of nothing. It calculates likelihood based on what has appeared before. When a large language model writes a sentence, it is predicting the next most statistically probable word, and then the next, and the next. That rolling probability chains creates coherence. Coherence feels like intelligence, but underneath it is pattern extension, not comprehension. That distinction becomes very important. The idea of artificial intelligence is older than modern computers. Ancient myths described mechanical servants. Philosophers imagined logic machines. In 1956, at the Dartmouth Conference, the term artificial intelligence was formally coined. The early researchers believed machines would achieve human level intelligence very quickly. They underestimated the complexity of human cognition. What changed in the last 2 decades wasn't a sudden discovery of digital consciousness. It was scale, more data, more computing power, more mathematical models. But what of we call now AI would once have been called advanced statistics. The difference is that statistics can now operate across billions of data points simultaneously. Scale transforms capability, and capability transforms impact. So AI isn't just one thing, but for practical purposes, you can think of three broad categories. Narrow AI, systems optimized for a single task, like spam filtering, fraud detection, face recognition. It does one thing. They perform extremely well inside defined boundaries. Generative AI, systems that produce content, so text, images, code, audio, video. They generate new outputs based on learned patterns. Then we have predictive systems, tools that can estimate probabilities. Who is likely to default on a loan? Which maintenance issue will occur next? Which applicant meets risk criteria? All of them rely on statistical pattern recognition, and all of them influence decisions directly or indirectly. AI doesn't need intention to change outcomes, it only needs to shape probability assessments at scale. Because AI outputs can sound confident, people sometimes attribute authority to them. When an output feels polished and precise, it is easy to assume it carries judgment. But the system does not evaluate truth the way humans do. It generates what is statistically plausible. If it produces an incorrect answer, it isn't choosing deception, it's extending a probability curve. If it produces biased output, it isn't expressing a new ideology. It's reflecting statistical imbalances in the data it absorbed. The system produces, humans interpret, and that boundary must remain clear. Otherwise, responsibility starts drifting into abstraction. So here's where AI's real influence lies. It compresses cognitive effort. Before AI, drafting required concentration, research required time. Now suggestions appear instantly. The risk is not primarily that AI generates errors because humans generate errors also. The structural shift is that speed reduces friction, and reduced friction can reduce scrutiny. When outputs arrive polished and immediate, acceptance becomes easier. This is related to automation bias, the human tendency to trust system outputs even when independent verification would be wiser. In aviation, pilots trained on autopilot systems sometimes overtrust automated signals. The same dynamic can appear in knowledge work. It accelerates suggestions. Humans may unconsciously decelerate skepticism, and that's not a moral failure, it's cognitive pattern, and AI amplifies it. So when we ask, what is AI? The surface answer is a system that detects patterns in data and predicts outputs. But the deeper answer is this: AI is a probability engine embedded into decision environments. It does not think, it calculates likelihood. It doesn't intend, it extends pattern. And it doesn't hold authority, but influences the way humans do. That's why it feels less magical once you understand it. Sorry about that. And more structurally powerful once you see where it sits. Artificial intelligence is not artificial consciousness, though. It is artificial pattern prediction operating at scale. Prediction can be extraordinarily useful, but prediction is not judgment. Judgment includes context, consequent, values, and responsibility, and those remain human. Understanding that boundary is not academic, it's operational. Because once you recognize what AI actually is, you stop asking whether it is intelligent, and you start asking how is it shaping our decisions and who remains accountable. That's where responsible AI truly begins.